Root test for positive series. Let's suppose that the limit of root order n of an equal L when n goes to infinity. Then we have three cases. If L less than 1, then the series converges. If L bigger than 1, the series diverges. And here L could be infinity. If L infinity, it's bigger than 1. So the series diverges. If L equal 1, then no info. This means sometimes in some exercises L equal 1 and the series diverges, and sometimes converges for some other exercises. Okay, so we need this rule in the exercises. So how to justify this rule or how to prove this rule? In fact, this comes from this exercise. Prove that the limit of root order x of x when x goes to infinity will be 1. And or this is the limit of x power 1 over x. How to calculate this limit when x goes to infinity? So to calculate this, let's suppose y equal x power 1 over x. Let's take ln of both sides. So it's ln x power 1 over x. It's 1 over x times ln x. So it's ln x over x. So what is the limit of ln y when x goes to infinity? It's the limit of ln x over x when x goes to infinity. So it's infinity over infinity. Let's use L'Hopital rule. So it's derivative of ln x. It's 1 over x divided by derivative of x. It's 1 when x goes to infinity. So the final answer is 0. So 0 is the limit of ln y. So how to calculate the limit of y? So now the limit of x power 1 over x when x goes to infinity is the limit of y when x goes to infinity. But y could be written as e power ln y when x goes to infinity. So it's the limit of e power without limits, because the limit of ln y is 0 here. So let's write 0 here without the term limit. So e power 0 is 1. Now the final answer that this limit of x power 1 over x is 1. So the limit of n power 1 over n when n goes to infinity also will be 1. So we have the rule here. We can use this rule in the next exercises. Test the following series. You know that this series is a geometric series, and we calculated the answer of this series. It's 1 over 1 minus a half, so it's a 2, so it's converges. But let's try to justify this using our method of root test. So let's take we have an, so this is method 1, now method 2. Method 2, let's suppose an is a half power n. Then what is root order n of an? It's a half. So what is the limit of this term when n goes to infinity? It's a half less than 1. Now by root test, so sigma an 0 to infinity converges. Let's take the next exercise. So here this is sigma an from 1 to infinity. So let's take the root of order n of an. It's root of order n of n power 3 over 5 power n. So it will be root of n order n power 3 over 5. Now, what is the limit of root order n of n? It's the last rule. When n goes to infinity, it's 1. So here it's 1 power 3 over 5. So it's 1 over 5. It's less than 1. So by root test, sigma n power 3 over 5 power n from 1 to infinity converges. Okay, let's take next exercise. So this is sigma an from 1 to infinity. Let's take root order n of an. So it's the root of 7 power n over the root of order n of n. So we can write this is 7 over root order n of n. So what is the limit when n goes to infinity? It's 7 over 1. The limit down is 1 using the last rule. So it's 7. 7 bigger than 1. Now using the theorem of root test. So by root test, we have sigma 7 power n over n from 1 to infinity diverges. Or you can write this sigma equal infinity. Let's take the last exercise. If we suppose this is sigma an, so what is the root of order n of an? So it's root of order n of 1 over n plus 1 power n. So it will be 1 over n plus 1. So what is the limit of this term when n goes to infinity? It's 0, 0 less than 1. Now using root test, by root test, so my series 1 over 1 plus n power n from 1 to infinity converges.